Hello everyone, we are Team 46. Our title is Shake but Not Too Complex, dimensional home in a new area. Enrique, how did you plan our project in the beginning?
I divided it into two parts for planning: building structural considerations and smart system. Building structural consideration will be introduced to Jenny. She's professional.
We first introduce the foundation from we choose. In the planning of IoT, we hope to have a sewage treatment system. However, the ref foundation provides a decent space to accommodate our sedimentation tank, and the ref foundation can provide the best effects in structure to resist the earthquake resistance emphasized in the title. Although the cost is much higher than other foundation firms, for the needs of our sewage treatment and smart home system when construction, in the end, we decided to use a ref foundation. That picture perfectly shows the advantages of ref foundations. It has enough underground space for our project. In the modern times, we mostly use SC, RC, and SRC as the main construction method. The first photo was taken in a park near the school. We can see that the current structure of the SC is very neat. It is characterized by fast construction, but the same high-altitude work during welding is more dangerous. The second photo was taken when I was working at the construction site. RC is characterized by the use of a large number of framework. The pile in the lower right corner is the framework. The third photo is of a bridge spanning a stream using only 3 piles. It can be seen that RC has the strongest support, which is better than the SC and RC I just said. Just now we decided on the ref foundation. Its assembly method is limited to SC. This time our project doesn't need too much floor.
RC. Limit to RC. Sorry.
Limit to RC. This time our project doesn't need too high flow. I think RC is enough to deal with the coming earthquake. Next up is structural safety. I don't know enough about boundary conditions, but what we can clearly see is the model plots a diagonal piece. The deformation of beams and columns will be reduced accordingly. I think the anti-deformation can also be applied to our model. I will talk about how we managed to solve it later. Next, hand it over to Enrique to introduce our smart home system, which is the master of IoT. Let us welcome him together.
Okay, thanks. We decided to apply the technology of IoT in the smart system. Use IoT to connect various sensors in series. The output data can use the powerful computing power of the computer to correctly grasp various situations inside and outside the house. The energy used is solar energy, combined with a little hydraulic. Pumped storage power generation concept converts gravitational potential energy into electrical energy. Don't worry about solar power not being able to generate electricity. on cloudy days. So next page. If we write programs, the content is an earthquake to quickly alert the user and instantly open the door of the main passage. Avoid the deformation of the door and the door frame after the earthquake and trapped in the house. In addition, we specialize in groundwater and rock formations. Ground subsidence caused by excessive groundwater extraction from towns near seaside of Yunlin for a long time and damage to the buildings. The microcomputer connects to the site and analyzes the data provided by the sensor. Pour the treated sewage into the groundwater in time manner. The most direct is to connect a pipe to the frontend. This system can also help control the watering situation. Avoid over-irrigation and soil salinization. Next, the model master will introduce our model.
Okay, let me introduce the model. First of all, we want to create a building within a flower pattern. There is a large piece of glass on the outside, a bit like a glass shutter, but at the same time building a spatial wall. The safety of the structure must be taken into account, and large windows will consume more electricity from the air conditioner. After consideration by structural engineer Elegay. He only allowed to remove the wall of the front of the house. When the screen right is our finished sketch. The next step is to follow the approximate location of the previous one. We plan the location for the columns and beams. It is important to build the actual size. When the model is released, it will be completely reduced according to the size. 1 to 27 is the most appreciated reticle for us, and our columns and beams take a similar approach. Cut all sides of model wood is one goal. Next is lofting. We procrastinate. Here for a lot of time. There are many errors when Elegay left the line. It is because Jenny didn't indicate the length and width of the column in dimensioning. In fact, the back of the board was painted very missed by Elegay. After confirmation, the pillars and the groundings are perfectly attached to the lofting plate. Use hot melt glue, like the picture on the right. The concept of boundary conditions mentioned earlier. Styrofoam glue joins more abruptly. Bonding. That should effectively reduce the deformation of the wall. Styrofoam glue pastes over the edge of the window, and we guess it can also reduce the deformation of the window. The construction of the wall requires the use of on-site construction. Some columns are not perfectly vertical to the ground. We need to use the ruler to measure the size of the model. The wall can be tightly connected with the column beam. The thinly soft cardboard is joined by styrofoam glue, and we are very satisfied with its strength. The only disadvantage is that the thickness of the wall cannot actually output 1:27 perfectly. Let me verify introduction to program. Use the signal of the button to simulate an earthquake. When receiving an earthquake, turn on the servo motor, turn 90 degrees, and change the light to red. If no analog earthquake signal is received, servo motor mentioned at 0 degrees position. Light stay white. Next, please introduce our finished products in detail and give him a line.
After finishing coding, let me introduce the finished model. First, this is how the model looks. However, in the simulation of the ref foundation, we thought of filling the soil with aggregate, but in practice, there are cement and steel bars that we can overcome. So the basement is not reflected on the model. See inside the model. The roof can be lifted. As for smart system, we don't have extra funds to build a solar power system. In total, we spent about $120 on the model. Next is our improvement. Back to our PowerPoint. Okay, back to our present. The picture on the left here is the back door of the model. Because we forgot to add 19 cm when we designed the door. The size of the actual living door is too small. Okay, the toilet on the first floor. Because the implementation steps are not systematically coordinated, only after finishing the exterior wall, I realized that a wall was missing. The start point of the arrow on the right is probably the position of the lens. That's like that. Okay. Originally, the teacher of Earth Science generously lent us an Arduino accessories. The only GY80 that can have both a gyroscope and a calorimeter as a calorimeter. The drivers are stopped supplied by third parties. I am guessing if there is a problem with the driver. After countless times of data output, the values are exactly the same from beginning to the end and are not logical. On the right is the origin edit program, but as mentioned above, the value is not normal. Generated many bugs. Finally, we decided not to use GY80 to simulate earthquake signal in the form of button. If time permits, we will refer to other types of sensors and help us realize the aforementioned ideas. So next to Jenny.
Let's talk about our group feelings and experience. Let's welcome to Enrique.
Okay, thanks. Hearing this competition at first, I feel like a stage for me. I'm excited to find team members. I would like to thank the teacher of Earth Science and my good friends who study civil engineering and his teacher how they led me. I think I have a solid understanding of basic building code. I can't wait to continue working as a structural engineer.
Hi, I'm Jenny. I want to share what I learned from the event with you. After nearly 3 months of discussions and ideas, I think we have accomplished an impossible task. From the initial conception of the structure of the architecture model in mind to the hand-painted completion of the model blueprint. From the script draft to the construction of the perfect house model, it is the result of mutual discussion among the team members. Among them, I learned how to draw blueprints and close teamwork. I want to share this joy and sense of achievement with you, and I believe this will be an unforgettable and valuable opportunity.
I'm attending ISC Holding 2021. In the process of making a model, I cooperated with my classmates, and we work hard to complete the works and participate in the competition, which made me know myself better, and so that my shortcoming also occurred. What I'm good at is very helpful my growth.
There must be a main structure that is sufficient, strong, and rock-resistant. On the top of this, can we build a smart IoT we need? This is the end of our presenting.